In 2020 October, each DreaM Incorporated invited the companies interested in demonstrating our non-combustible next generation FRP and the non-combustible heat insulation.
わざわざのお越しありがとうございました。私どもは昨年10月に、開設をしましたまだ新しい1年経った企業でございますが、我々スタッフこの1年全力で走ってまいりました。その結果として、私どもの開発をしました複合材料、それに断熱材、この2点がですね ISO の、1182という、いわゆる不燃性試験というものにおかげさまで合格することができました。
Following the chairman's greetings, we displayed the superb abilities of the non-combustible FRP and non-combustible heat insulation with a 1200 degrees centigrade, 2192 degree Fahrenheit blowtorch. The next generation FRP is a new material with the same nature and quality as the usual FRP and can be used in the same manner. Strictly speaking, it is an FRC, fiber reinforced ceramic, reinforced with basalt cloth, but for simplicity, we call this material next generation FRP. A general non-combustible FRP instantly catches on fire and creates smoke. Each DreaM's non-combustible next-generation FRP will withstand the fire for over 3 minutes without burning or emitting smoke. Styrofoams are excellent heat insulators, but are prone to heat and burns quickly. However, if you spray on our non-combustible heat insulation, the Styrofoam is now fireproof. The insulation is so effective that you can even hold your hand over on the opposite side. This Styrofoam, stuck with 5 pieces of our non-combustible next-generation FRP, shows its effect as it bears heat without burning for over 3 minutes. This is a low heat conducting sample to simulate application to an industrial complex. The side directed with fire is a steel plate, and the heat insulation is approximately 26 millimeters, 1.02 inches thick. Even after 5 minutes of fire exposure, the temperature of the other side was 19 degrees Celsius, 66.2 degrees Fahrenheit. Here is a sample cardboard piece, plastered with non-combustible heat insulation. Now a blowtorch won't burn this paper. Calcium silicate board is a material that is difficult to burn and is applied in many houses. However, it becomes brittle in extreme heat and breaks. Even if you were to combine them with standard heat insulation, it would transmit heat, causing the insulation to burn and emit harmful gas within a minute. By combining our non-combustible next-generation FRP and non-combustible heat insulation, you'll be able to save countless lives from the fire. You can spread this non-combustible heat insulation with a trowel or spray it on by adjusting its consistency. Here is a board used in the demonstration, dried at room temperature, exposed to a blowtorch. With its simple procedure and reliable effect, we can hope for its application in fireproofing reforms for homes. We are now comparing the combustion between a box built with calcium silicate board and heat insulation foam and a box sprayed with our non-combustible heat insulation. The white box on the right is the calcium silicate board, and the black box on the left is our spray-on non-combustible heat insulation. For the spray-on heat insulation box, we poured in kerosene to expose the inner sides to the fire as well. The calcium silicate and heat insulation is a standard combo in houses, so this experiment is recreating a fire breakout in a standard room. The calcium silicate board breaks easily due to the heat. The 4 wooden pillars are burned as well. Unfortunately, our spray-on heat insulation did not show a perfect result due to not being thoroughly dried. But despite the inside's blazing fire, the 4 wooden pillars were left unburnt, and the box relatively kept its shape. Here we examine the heat conduction and heat insulation of an industrial complex and the veranda shelter's performance. This is the non-combustible veranda shelter that will start distribution within the year. By replacing the current veranda with this product, it will work as a storeroom during regular times. Each DreaM's veranda is unique, as it is fireproof and waterproof. In a fire breakout, you'll be able to escape via the veranda trapdoor and stairs. We simulated a non-combustible hallway between the room and the veranda, and a staircase inside the non-combustible veranda. Simultaneously, we inserted a kerosene-filled can in a heat-insulated box, simulating a fire at an industrial complex. The staircase inside the veranda is not affected by the heat. This proves that even when engulfed with fire, the veranda will function as an escape route. However, the hallway had bent from the heat as we hadn't applied insulation. Although it didn't burn, this experiment taught us the need to process a safer passage. The kerosene-filled can was not affected by the heat. The kerosene inside was not affected as well until we set it on fire for another occasion. These results show that it is possible for application on industrial complexes. Our heat insulation will also utilize houses with reinforced concrete. In this experiment, a steel reinforcing rod is placed over the kerosene-filled container as a fountain for the hut. Steel rods bend at 500 degrees centigrade. In a fire, it becomes like the condition in the video. By covering them with non-combustible next-generation FRP and non-combustible heat insulation, we can create a reinforced concrete house that's strong against fires. Here, we have aligned 3 houses and recreated a catch fire situation for the middle house. In the house on the right, a box made with non-combustible heat insulation portrays a room, and inside that, we have put ice. The house in the middle is made of wood, but is treated with non-combustible next generation FRP and non-combustible heat insulation. At the house on the left, we will simulate an AI firefighting. An RC tank protected with non-combustible material will drive through the non-combustible hallway. The objective is to keep the RC functional in the burning house so that an AI firefighter can extinguish the fire from the inside. Unfortunately, the heat had seeped in from under the RC cover and immobilized the tank. Also, the heat had collapsed the house on the right and spilled the ice. But we were able to prepare a new batch and left it in the fire once again. We have succeeded in showing that the ice would not melt. At this point, we have poured kerosene 7 times into the fire, creating harsher circumstances. Although the fire had engulfed both houses on the sides, the house in the middle kept its shape. The next day, we cut the roof and confirmed that the inner wood material was perfect with no heat damage. I believe this is proof that we can build fire-resistant houses. We also redid the AI firefighter 4 days after the demonstration. From the last failure, we laid ice packs on the passage to prevent the caterpillar from melting. You can fireproof the vehicle's body itself in an actual situation, so creating an AI firefighter that can get ultimately close to the fire will become a reality. Here is a fire retardant made from improved liquid form non-combustible next generation FRP and non-combustible heat insulation. The first liquid quickly suppresses the fire as the second one solidifies the fire's origin, keeping it from burning further. These two combined fire retardants will extinguish fires still burning from residue kerosene.
今現在で耐熱、断熱、熱伝導率は世界で飛び抜けてトップだと思っております。熱伝導率に関しては全然氷が溶けないということ、こんなのありえない。で、燃えないですね。まあ見てもらった通りです。僕たちは、本当にただの材料屋ですので、皆さんがどういうものを作ろうかっていうことを、例えばこの帰り道でも想像してくれるような商品だったら何卒よろしくお願いいたします。本日はどうもありがとうございました。
Although this experiment dealt with violent fires, the demonstration ended without any significant accidents. We were not able to present a 100% satisfying result due to insufficient preparation and settings. However, this has not deterred our confidence in our product. We hope to collaborate with companies with incredible skills to develop and challenge the world. to deliver the potentially life-saving product to people worldwide, we will keep improving and disseminate it to the world.